All right, this is the 4-2-4-3 review. So number one here, we want to find the unknown angle measures in each triangle. So we're going to start with a linear pair. Where are they? There we go. All right, so these two angles here are a linear pair. They should add up to 180 degrees. So if we do 180 minus 125, we're going to get 55. Okay, so the angle in here is 55 degrees. Right, and that is a base angle of our isosceles triangle. So this triangle has two sides that are congruent. So this is a leg, this is a leg, and this is the base. So the base angles would be these. So that's 55 and 55. And then the third angle of our triangle, we can subtract the first two from 180. So 180 minus 55 minus 55 is going to give us 70 degrees. So angle K here would be 70 degrees. So 55, 55, and 70. Okay, over here, we have an isosceles triangle. So the two base angles, right, the two legs. So the base angles would be angle S and angle T. So if angle S is 3x minus 2, this one down here will also be 3x minus 2. Right, and then we can put in our equation here. The three angles of the triangle add up to 180. So 3x minus 2 plus 3x minus 2 plus 9x minus 4. All three of those angles will add up to 180 degrees. Okay, and then we can combine like terms here. So we have 3x, and 9x. That gives us a total of 15x. Okay, and then negative 2 is negative 4. This should have been plus 4. So then negative 2 minus 2 is negative 4. Plus 4 is going to give us 0. So it should be 15x equals 180. And then we divide by 15 on both sides. And that's going to give us x equals 12. And then we can plug that in. 9 times 12. I don't know why I'm having such a hard time writing. Nine times 12 plus 4. That's going to give us 108 plus 4 is 112 degrees. Okay, and then 3 times 12 minus 2 is going to give us 36 minus 2 is 34 degrees. Right, so this one is 34. And then this one down here is also 34 degrees. Okay, 34, 34, and 112. All right, the next one, the two legs here, right? So our legs are across from the base angle. So this side and this side, those are the two legs, right? So our two legs are equal to each other. So 3x plus 4 equals 10. We subtract 4 from both sides, and we get 3x equals 6. We divide both sides by 3, and we get x equals 2. Okay, we plug in 2 here. 2 plus 3 is going to give us 5. And then 3 times 2 plus 4 is going to give us 10. So you have 10, 10, and 5. Okay, over here, so across from the base angles are going to be the congruent sides, the legs. So these are our two legs here. So 4x plus 1 equals 29. We can subtract 1 from both sides, and we get 4x equals 28. And then you divide both sides by 4, and we get x equals 7. Okay, then you can plug it in. So 7 times 7 minus 1 is going to give us 48. And this is 29. And then 4 times 7 plus 1 is 28 plus 1, which is 29. So we have sides 29, 29, and then 48. Okay, 5 through 7 here. Triangle ABC is an isosceles triangle. Right, ABC here is an isosceles triangle. And so angle B, if that's 67, that means angle C down here is also 67. Those are the base angles. If this is a right angle, it's 90 degrees. And this one would also be a right angle, so that's another 90-degree angle. Right? We can just look at one of the triangles to find the measure of angle DAC then, right? So if we just look at one of these triangles, we know the three angles of a triangle add up to 180. So 180 minus 90 minus 67 is going to give us a total of 23. So this angle here is 23 degrees. And it'd be the same for the angle up here. This also right here would be 23 degrees. Okay, so the measure of angle DAC is 23 degrees. All right, the sides here. So let me actually, that's the angles. Okay, so let me actually erase this and let's look at the sides. So here's our triangle, ABD. We found out that we were bisecting the vertex angle. So if we bisect that vertex angle, right, this was 23 degrees and this was 22 degrees, then our bisector is also a perpendicular bisector of the base. So if DC is 10, then BD is also 10. Okay, and so now we have a triangle with 24, 10, and we have a right angle. So we can use the Pythagorean theorem to find the third side of our triangle X. So we're going to use the Pythagorean theorem here. A squared plus B squared equals C squared. Okay, the hypotenuse here is X, right? This is the hypotenuse across from the right angle. And so the hypotenuse is going to be our C. And then the two legs are going to be 10 and 24. So we're going to have 10 squared plus 24 squared equals the hypotenuse squared, and let's just call it, we're calling it X. So that's X squared. Okay, 10 squared is 100. 24 squared is 576. If you add those together, that's 676. To get rid of a square, you have to take the square root. So we'll take the square root of both sides. If you do it to one side, you have to do it to the other. And that's going to leave us with 26 equals X. So we know the length of AB here is 26. AC would also be 26. So AB is going to be equal to 26 units. Right, and then BC, right, we said if DC was 10, BD was 10. So BC, the whole thing here is 10 plus 10, which is 20 units. Right, 8 through 10. Okay, 8 through 10. So the first triangle I want to look at is triangle PTQ. This triangle right here. Okay, we notice it's a right triangle. So we notice this is 90 degrees. And then we notice it's an isosceles triangle. We have two sides that are congruent. So if it's isosceles and we have the vertex angle, 90 is the vertex angle, we can do 180 minus 90, which is 90. So we know these two angles add up to 90, and we know they're equal because it's isosceles. So we divide by 2 and we get 45. So we know this angle here is 45 degrees. And we know this angle down here is 45 degrees as well. This one right here. All right, and so PTQ, angle PTQ right there is equal to 45 degrees. If you look at another triangle here, how about triangle RPT? Okay, we notice it's isosceles as well, and its vertex angle is 60. So if the vertex angle is 60, it's going to be equilateral. And if we just show you that, if we do 180 minus 60, we get 120. And then we divide by 2, and we get 60 degrees. So this angle right here is 60 degrees. And then this angle here is 60 degrees, right? So 60, 60, 60. So if we look here, these two little angles, so angle QTR, which is the next one we're trying to find, plus 45 should add up to 60. So if we do 60 minus 45, that's going to give us 15. So this angle right here, angle QTR, right, is going to have to be this angle right here. Has to be 15 degrees. Right, so 15 plus 45 gives us 60. So QTR is 15 degrees. Right, and then the last triangle we have is an equilateral triangle. We know the three angles of an equilateral triangle are 60 degrees. So we know the three angles of this triangle are 60, 60, and 60. And then the last triangle or last angle we're trying to find is angle PTS. So angle PTS is this entire angle here. So that's going to be 45 plus 15 plus 60. So 45 plus 15 plus 60, which is going to give us 120 degrees. So the orange one there is 120 degrees. So you can do the blue one here, 60 plus 60 is 120, or you can do 45 plus 15 plus 16 is 120 degrees. All right, the next question here on what is the measure of angle JKL? Well, it's an equilateral triangle, so this one is 60, just like the other angles are also 60 degrees, right? The three angles of an equilateral triangle are 60, 60, 60. So this is 60 degrees. All right, label each pair of triangles by side, angle, side, 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 or not enough information. So over here, we have two pair of sides. The angle is between them. So we have side, right? There's one pair of sides, right? Angle, side. And then there's a second pair of sides. So these are congruent by side, angle, side. Over here, you have one pair of sides. You have two pair of sides. And then you have a third pair of congruent sides. So we can use side, side, side to show the triangles are congruent. Or if you want to add in your vertical angles, we know all vertical angles are always congruent by the vertical angle theorem. We then have side, angle, side. Right, so either one of those is fine. Okay, this one, we have two pair of congruent sides. One pair of congruent angles. Right, but the angle is not between the two sides. In order to use side, angle, side, we would need angle F to be congruent to angle L. Then we would have side, angle, side, but this one would be side, side, angle, or you could say angle, side, side, which is not enough information. We don't have enough information. Maybe these triangles are congruent, maybe they're not. If you have angle, side, side, there's two different types of triangles we could make. All right, this one you can add in your vertical angles, and then you have side, angle, side. So these two triangles would be congruent by side, angle, side congruency. All right, the proof here. The first step is always your given, right? So that was given, right? The Wx is congruent to xy and Bx and xc, right? Really, it should be congruent, not equal, right? Congruent, congruent. But that's fine. Okay, vertical angles are Wxv and Yxz. So we can say angle Wxv is congruent to angle Yxz. That's the vertical angle theorem. And then we know the triangles are congruent by side, angle, side, congruency. And if the triangles are congruent, we therefore know the corresponding parts are congruent. So the corresponding parts of congruent triangles, CP, CTC. And that tells us this other pair of angles here, W, VX is congruent to angle Y, ZX. So that's what we're trying to prove. That goes right down here. Angle WVX is congruent to angle YZX. 14, we don't have to worry about, okay? It depends really. I mean, you can use the Pythagorean theorem here, right? So reflexive, and then if we use the Pythagorean theorem, we know this piece and this piece are gonna come out the same because we're using the same formula. And then you can say yes by side, side, side. Or, you know, if you don't think of the Pythagorean theorem, we could also say no. You could also use opposite sides of rectangles. So it's just, we don't know. Okay, we don't know. I mean, we do, but we don't need to worry about it. So just skip 14. I shouldn't have put it on there. All right, number 15, 16, 17, and 18, we're finding angles of triangles. And so we look for vertical angles in linear pairs if we're starting here. So this is a linear pair. So 180 minus 118 is going to give us 62. So 180 minus 118 is going to give us 62. Right, here is our triangle then. Okay, so this is a leg. This is a leg. And this is the base. So if this is the base, this is also 62. Okay, and then we have our other triangle. We know that these two angles down here are going to add up to 90 degrees because there's a right angle here. So 90 minus 62 is going to give us 28. Okay, and then if you look at this triangle, right here we have a leg. Here we have a leg. And then this is the base. So this angle here is also 28. So we can do 180 minus 28 minus 28. And that gives us 124, right? 120. Right, 66. I'm sorry, 56, right? And then 180 minus 56 is 124. Yep. Okay. 16. So you have 109. So we have a linear pair. So 180 minus 109 is going to be 71. And again, here's a leg. Here's a leg. So if that's 71, this one over here is 71. And then we know the three angles of the triangle add up to 180 degrees. So 180 minus 71, that's minus 142. It's going to give us 38. Okay, and then this is a right angle. So we can do 90 minus 38. It's going to be 52. So this angle here is 52. Then we have another isosceles triangle. So this is a leg and a leg. That means this is the base. So if this is 52, this one right here is 52. And then you have a linear pair. So they add up to 180. So 180 minus 52 is going to be 128. So this angle here is 128 degrees. And that's X. 128 degrees. Okay, this one we're finding the measure of angle ABC. So if we look at our equilateral triangle, we know the three angles are going to be 60 degrees. So 60, 60, and 60. Right, and then we can fill in our isosceles triangle as well. So this is our isosceles triangle. Here's a leg. Here's a leg. So the base here is the bottom, AD. So angle A is 64, and then angle ADB is also 64. And then to find the third angle of that triangle, we can do 180 minus 64 minus 64. And that's going to get us 52. So this angle right here is 52 degrees. And the question is, what is the measure of angle ABC? That's this angle right here. So ABC would be these two angles added together. 52 plus 60 gives us 112 degrees. This one over here, equilateral. So we're going to do 60, 60, 60. Okay, it's telling us angle ADC is 102 degrees. So here's angle ADC. So this big angle here is 102 degrees. So that means these two smaller angles have to add up to 102. So if we do 102 minus 60, that's going to give us 42. And so this angle has to be 42. 60 plus 42 is 102. And then we notice this is isosceles. So the base angles are angle BDA and angle A. So this one is also 42. Okay, and that's the angle we're solving for. Find the measure of angle BAD. That's 42 degrees. 42 degrees. All right, on to the proofs. Okay, so here we're going to want to do statements and then reasons. Okay, let me try to keep it organized here. All right, so the first thing we have is our given. So we know that MT bisects angle ATH. Let me call this step 1. Okay, and that is given. We also know that AT is congruent to, let me just write it in. It's not a lot to write. So for step 1 here, we have MT, should be segment MT bisects angle ATH. And the other thing that's given is AT, should be segment AT is congruent to segment HT. And these is given. Okay, I would mark that in our diagram. So AT is congruent to TH. Okay, if we go down the list that's on the board, we're looking for shared sides. We do have a shared side here. The side that's being shared is MT. So we can use the reflexive property. So segment MT is congruent to segment MT. That is the reflexive property. Right, and then midpoint, we don't have any midpoints. Alternate interior angles, we don't have parallel lines for alternate interior angle theorem. And then bisector, angle bisector is the last one, and we do have an angle bisector. Okay, so MT, that's this line right here, is going to bisect angle ATH. So if I highlight, here's angle ATH, that means we're going to split that angle into two congruent pieces. So that's angle ATM is congruent to angle HTM. So step 3 here, we're going to say angle ATM is congruent to angle HTM. And that was the definition of an angle bisector. So that is an angle bisector. Okay, and then we now have side angle side. So side angle side congruence criterion is going to tell us that triangle MAT is congruent to triangle MHG. Okay. But the big one there is the bisector. So you have to figure out what you're bisecting. We're bisecting angle ATH. And so we're splitting that big angle, this big angle right here, ATH, into two equal pieces. And there's our proof. Okay, the next one, let's do the same thing. Let me write statements and reasons. Reasons. Oops. All right. All right, so we're going to start with the given. Okay, so C is the midpoint of AE, segment AE. And then C is the midpoint of segment BD. And that is given. Okay, if we go down the list, do we have a shared side? No, we don't. So we're not going to use reflexive or symmetric. Do we have vertical angles? Yes, we do. So we are going to use the vertical angle theorem. So we're going to use the vertical angle theorem. And that tells us vertical angles are congruent. So our vertical angles here are angle ACB. ACB is congruent to angle ECD. Those are our vertical angles. They are congruent. Okay. So there's vertical angle theorem. Keep going down the list. Midpoints. Yes, we have two midpoints. C is the midpoint of AE and C is the midpoint of BD. So here's AE. So if C is the midpoint of AE, then AC is going to be congruent to EC. So AC is congruent to EC. Right, and then if C is also the midpoint of BD, then segment BC is going to be congruent to segment CD. So BC is congruent to segment DC. Right, and then you have side angle side congruence. All right, so this was definition of midpoint. Okay, and then now we can say the triangles are congruent. ABC is congruent to triangle EDC. And that is by side angle side congruence criterion. Side angle side. Okay, so vertical angles, midpoint, midpoint, that gives us two pair of sides, one pair of angles, side angle, side. All right, last one, they already have this written for us. So let's start with our given. Okay, so we know that MH is parallel to AT. Again, these should all be segments, right? And we also know that MH, again, it should be segment MH, is congruent to segment AT. So we fill in the diagram, MH is congruent to AT. We also know that these lines are parallel to each other. All right, do we have a shared side? Yes, we do. And H in this triangle is going to correspond with A in the other one. And A in the top triangle is going to correspond with H. So they're running in different directions. So we're going to use symmetric property this time instead of reflexive. So symmetric. Right, so HA, segment HA is going to be congruent to, instead of HA, we're going to do AH. Okay, and that's this one right here. So now we have two pair of sides. Then we can keep going down the list. Vertical angles. We do not have vertical angles. Midpoint. We do not have a midpoint. Alternate interior angle theorem. So in order to use the alternate interior angle theorem, we need parallel lines. And lucky for us, we do have parallel lines. So let's highlight those parallel lines. MH is parallel to there we go. MH is parallel to AT. So then AH is our transversal. Right there. And so our alternate interior angles are going to be this angle right here and this one right here, right? Those are going to be our alternate interior angles. If the lines are parallel, then those alternate interior angles are congruent. So how do we name those angles? Well, this one's going to be MHA. So angle MHA is congruent to angle TAH. And that is the alternate interior angle theorem. Alternate interior angle theorem. If the lines are parallel, alternate interior angles are congruent. Okay, and we can now use side, angle, side. So if I delete these lines, right, we can clearly see we have side, angle, side, triangle congruence. Right, which tells us the triangles are congruent. So triangle MAH is congruent to triangle THA. And that's it. We've proven it. The triangles are congruent. Okay, so that's the end of the review.